Welcome friends, welcome to the Python Novice to Pro channel, and in today's video I'm going to show you how you can use the SQL SELECT statement to run queries in SQL. First, in this video I'm going to define the SQL SELECT statement, show you the syntax of the SQL SELECT statement, and then we'll give you 5 applications you can use the SQL SELECT statement, such as selecting all columns from a table, selecting rows from multiple tables using a join, or transforming data with functions. So let's begin the video on a right note. What is the SQL SELECT statement? The SQL SELECT statement retrieves data and shows it as a table. For example, if you have a table and you say, okay, I want you to show me some specific use cases from that table, like show me, if it's a customer table, show me the number of customers that have purchased an item within a certain period, or show me the number of purchases I had today. Those are some of the functions you can get from the SQL statement. And the table that you are given as a result is called the result set or the results table. Now, what is the syntax of the SQL statement? The SQL statement has 2 syntax. For example, we have the syntax for the select star when you want to retrieve all the columns in a table from a database. And then we have the syntax for retrieving specific columns from a database. And for the two, it may be based on some criteria such as a where clause, a group by, order by, and whatever. I'll show you all the syntax in a moment. But now, let's go to the 5 applications I want to show you can use a SQL statement for. These 5 basic applications are what you usually find when you are working. And what I'm showing you, I'll start with the SQL statement. So I'll go to my MySQL database using my VS Code extension. I showed you how to connect to the database using VS Code in my first video on SQL. I'll encourage everyone to watch that video if you want to practice along with this video. Watch that video and install the MySQL on your local machine so you can practice. But if you don't want to practice, you can learn something just by watching this video, and you can use it on your own work in the office or as a hobby. Now, the first application is showing all the information in a table. That's the first syntax, the select star. For example, let's go to this enterprise relationship diagram, or an EROD. This for the database we are going to be using, the farmers markets database. We have some tables here such as the customer purchases, the vendor, and the vendor inventory. For example, I have a transactional table here, the customer purchases, and I want to see all the transactions that have been done to date on the customer purchases table. To do that, we'll use the select star statement. I'll say select star, select all from farmers market dot customer purchases. So I'll run the query now. So you see all the information in the customer purchases table. There's another query you can run to find how many rows this results that table has. Just stay tuned to my channel and I'll show you everything later. So we can see that the result set has several columns. We have the product ID column, the vendor ID column, the market date, the customer ID, the quantity, the cost to customer per quantity, and the transaction time. And it runs right from the start of customer purchase to the present time when the database was collected. So this is the first application, retrieving all the information in a table. We use the select star. Always remember that. Select with the star mark here. That's the first syntax and also the first application. Now, what if we don't want to retrieve all the columns? We say, okay, some of the columns, like I don't want to see the transaction time, I don't want to see the market date, I just want to see some specific columns of interest. That's when we use the second syntax, selecting specific columns from a table. For example, I just want to see only the customer ID, the quantity, and the cost to customer per quantity. So I'll remove this star here and I'll insert only the columns I want to see. I say customer ID, quantity, and cost to customer per quantity. So let me run it. Let me remove this result table and rerun the query again. This is second syntax. Good. So you now see that in the customer purchases table, I'm seeing only the customer ID, the quantity, and the cost to customer per quantity columns. And we have lots of rows for this, with some of the information in customer ID repeating. That shows us that some customers have purchased several times. You might be wondering why I put this farmers market dot customer purchases. Is because we are retrieving the information from the farmers market database. So the query machine needs the database information because it's querying a MySQL server remotely. So it needs the database information. But in some query machines, you don't need the database information. So that's the second application of the SQL select statement. Good. Now, what if we want to select certain rows that meet certain criteria for the third application? For example, I want to find out what are the before I find out, let me just show you the table I'm going to reference. I'm going to reference the vendor inventory table, this one. You can see that it has the market date column, the quantity column, the vendor ID, the product ID, and the original price. So in the vendor inventory, I want to find out which vendors have original prices above the average price. So you see our filter criteria is prices, original prices above the average price. So we want to see a table of vendors with their original prices where all the original prices are above the average original price. We could calculate the original price manually. Let me show you how you can, but it's not ideal. For example, I could say, let me calculate the average price for original price manually. I just do select avg farmers market dot vendor inventory. It will now give me a single value. If you give me a single value, it says 9.058896. 9.058896. That's the average of all the vendor original price. Now that I've gotten the average, I'll say, okay, I want to see what columns do I want to see. I want to see the, from the vendor inventory, I want to see the vendor ID. I want to see the vendor ID, the product ID, and the original prices that we are selecting from. So I'll say select vendor ID, product ID, and original price. Now remember, we are saying give us only the original prices that is above the average price. So we could now say where is used as a filter condition, where original price is greater than, I calculated it manually before, and we calculated it as the average price as 9.058896. 9.058896. Now let's run the query, but I don't ask you to do it this way. I'm just showing you what is possible. You can see that we have vendor ID 8 with product ID 7. These are the original price. There is repetition. There is a way we could remove the repetition by grouping the data. We could remove the repetition, so we could see that only one vendor ID and product ID have original price above the average. But instead of doing this, calculating the average manually in the select statement, I could use what is called a subquery. That is a query within a query. Let me show you how it's run. I will say I'll use another select, and I'll calculate the average. I'll calculate the average of the original price. Inside that, let me close this so it will show clearly. Create the average inside the subquery farmers market dot vendor inventory. So you see, this is a subquery used in the selection. So now let me run it again. You see we get the same information. So you could use it both ways, but I recommend doing it this way, creating a subquery inside your original query instead of calculating the average price manually and then writing it down. That's a cake. I don't recommend that. So that's a third application of the select SQL select statement. Now another application of the SQL select statement is selecting rows from multiple tables using a join. Now you understand this if we use an example. Let me go back to our entity relationship diagram. Let's see if we can, okay, we have the customer table and the customer purchases. Now what if I ask what customers have made purchases? It's not every time we have a customer that they make purchases. Some customers just want to register and they remain dormant, but some customers make purchases. So want to see what customers have made purchases. So we'll get that information from two tables, from the customer table and from the customer purchases table. Then we'll join the information together based on where there is an intersection between both tables. And SQL select statement is good for that. For example, in the customer table, I would like to see here the customer first name, the customer last name, and then the customer purchases table, I would just like to see the quantity that was purchased. So this three information is just what I need. Now let me show you how we could use a select statement for it. I'll not give you the columns first. Let me just run down the architecture of the query. I'm joining. So I'll first say I'm joining from the customer table, and I'll say let it have the alias C. I'll show you why later. Then I'll join it to the customer. Is that customer purchases? Yes, customer purchases. Customer purchases. I'll give it alias CP. I'll tell you why I'm giving you the alias later. Then I'll join. What key will I use? Because if we are going to look for intersection, we need a key that reconciles between both of them. Let's look at the entity relationship diagram. We see that the relationship between customer and customer purchases is a one-to-many. That means one customer can make several purchases. That's it. So the key that connects them is the customer ID. You can see the primary key on the customer is the customer ID, and the foreign key on the customer purchases is the customer ID. So the key we'll use is the customer ID. So on says what is the key? We'll say C dot customer ID to CP dot customer ID. Now, why did I use C and CP instead of customer and customer? Because sometimes when you are joining two tables, they might have the same column names. So we use aliases to differentiate between them. Like in this example now, I'm going to say, okay, from the customers, I want to see the customer first name and customer last name. So I'll just say C dot customer first name, C dot customer last name, to show that customer first name and customer last name is gotten from the customer table in the join. And then in the customer purchases table, I'm looking for the quantity, so I'll say CP dot quantity. Now I've got all I need. So just watch this query now, how it will run. This is just an application of how select can get to data from more than one table, joining them together. Okay, sorry, I didn't select the data. It's saying no database selected. So I said because of the query engine needs a database, let me put the database farmers market. So here to I put farmers market. Okay, so it's run now. See, so to give us a rundown of customers who have made purchases, and it repeats. Don't mind the repeats. In subsequent videos, I'll show you how you can remove the repetitions, maybe by aggregation or filtering out column. But we can see Jane Connor has made purchases of 2.09 quantities. 1. Manuel Diaz has made quantity purchase of 1. Bob Wilson has made purchase of 1, and so on and so forth. So this is also an application of the SQL SELECT statement. You see how versatile the SQL SELECT statement is. Very versatile. Now, one thing you can do with the SQL SELECT statement is to use it to transform data. Whenever I'm doing data cleaning in my data analysis work, I use this once in a while when pandas gives me the headache. So I go to SQL and transform data. For example, let's see in this, what table will we use to demonstrate? Okay, let's use a table we have not used before. Vendors. We have vendor ID, vendor name, vendor type. We'll say, how do we transform these vendor names? These vendor names, let me see if it's uppercase or lowercase. Vendor name. Let me see how the vendor name is organized. Farmers market dot. What table is that? Vendor. Vendor. Okay, it's in lowercase, all the vendors. Okay, we'll say, what if we want to show this information in uppercase? That's a transformation of the data. I'll just say upper. I'll use the upper function. See how the results runs this time. So you see all the vendor names are uppercase. Now compared to this one where we didn't use the upper function, and this where we use the upper function. So you see, the SQL Select can also transform your data, ensuring that you can clean it. You can clean it, you can filter, you can transform. So I'm sure you now have a good grasp of what you can do with the SQL Select statement. I implore you to go through, practice it on your own. You can download the EROD diagram from the first video I talked about how to install the farmers market database. You go through it, go through this video and see how you can practice it on your own, and you become a SQL ninja in a short while. So thank you for watching this video. I encourage you to subscribe to this channel and also like this video, because it encourages me to build more videos like this. Goodbye.